15 years ago this month, the first NASA robots arrived on Mars. And to mark the anniversary, the space agency has released these spectacular images of the red planet.
NASA's Mars rover Perseverance has sent back some of the most amazing footage of the red planet. Using its advanced cameras and high-tech equipment, it has captured ultra-clear 4K images that make us feel like we're right there on Mars. However, Perseverance continues the work of the Curiosity rover, which also gave us stunning 4K images of Mars. Both rovers are helping to push the limits of space exploration. But why is NASA spending billions of dollars on these missions? Join us as we uncover the incredible footage of Mars sent by both rovers. A fresh perspective on Mars. For decades, robotic explorers known as rovers have played a key role in helping us learn more about Mars. NASA has sent several advanced rovers to the red planet, each one more sophisticated than the last. These missions, spanning over 20 years, have revealed astonishing insights about Mars' past, its environment, and the possibility that life once existed there. The journey began in 2003 when NASA launched two twin rovers, Spirit and Opportunity. Their main mission was to search for signs that water once flowed on Mars. The data they sent back provided strong evidence that Mars was not always the dry, barren world we see today. It once had conditions that could have supported life. Then in 2012, Curiosity took the mission to a whole new level. This rover landed in Gale Crater, a region thought to have once held a lake, and began analyzing Mars' climate, geology, and overall habitability. With its high-resolution cameras and powerful instruments, Curiosity gave scientists an unprecedented look at the planet's surface. In 2021, Perseverance arrived, equipped with the most advanced technology yet, to search for ancient signs of life and collect rock samples that could one day be returned to Earth. Thanks to these rovers, we now have breathtaking images of Mars and a much clearer picture of its history. As part of NASA's Mars Science Laboratory mission, Curiosity was launched from Cape Canaveral on November 26, 2011. It then traveled an astonishing 350 million miles across space before making its dramatic landing on August 6, 2012. After an intense entry, descent, and landing sequence, often called the 7 minutes of terror, Curiosity safely touched down in Gale Crater, near the base of Mount Sharp, a towering 5.5-kilometer high mountain. From the moment it arrived, Curiosity had a clear goal: to explore the planet's climate and geology, and, most importantly, determine whether Mars could have ever supported microbial life. Gale Crater was chosen as the landing site because scientists believed that it once contained liquid water, making it an ideal place to search for signs of habitability. To uncover these secrets, Curiosity was equipped with an impressive suite of scientific tools. One of its main objectives was to analyze the composition of Martian rocks and soil. It carried instruments designed to detect key elements essential for life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. One of its most fascinating tools, the ChemCam, used a laser to zap small portions of rocks, turning them into plasma. By analyzing the light emitted from this plasma, scientists could determine the chemical makeup of the rocks, helping them piece together Mars's geological history. This analysis provided clues about past volcanic activity in the presence of water. But Curiosity didn't just study the ground. It also investigated Mars's thin atmosphere. It measured the cycling of water and carbon dioxide, shedding light on how the planet's climate has changed over billions of years. This research helped explain how Mars transitioned from a warm, possibly habitable world to the dry, freezing desert we see today. Beyond searching for signs of past life, Curiosity also played a crucial role in preparing for future human missions. One of its key tasks was to study radiation on the Martian surface. By measuring cosmic rays, solar proton events, and neutron levels, the rover helped scientists assess the risk astronauts might face when they eventually travel to Mars. The data collected by Curiosity has been nothing short of groundbreaking. It has reshaped our understanding of Mars's history and continues to provide insights that could one day help humans explore and perhaps even colonize the red planet. As we look toward the future, one thing is certain: rovers like Curiosity have paved the way for the next giant leap in space exploration. But how did we accomplish such an incredible feat? Let's dive into the story of one of the most famous rovers and how it changed our understanding of the red planet forever: Curiosity rover discovery. In 2013, NASA's Curiosity rover made a game-changing discovery on Mars. It found strong evidence that water once floated through the Gale crater. Scientists identified an ancient stream bed, suggesting that Mars may have had rivers or lakes in the distant past. Even more exciting was the discovery of clay minerals, which only form in the presence of water. This supported the idea that Mars once had conditions that could have supported life. But Curiosity's discoveries didn't stop there. The rover also analyzed Mars' atmosphere and found unusual methane levels. On Earth, methane is often linked to life, but it can also come from geological processes. Curiosity has transformed how we see the red planet. Using its powerful cameras, especially the Mastcom, it has sent back breathtaking, high-resolution images of Mars. These pictures reveal towering mountains, deep valleys, and vast rocky plains, giving us an incredible look at the planet's ancient landscape. The rover itself is an impressive machine. It was built using lessons from NASA's earlier Spirit and Opportunity rovers, but with major upgrades. It's about the size of a small car, weighing nearly 2,000 pounds and standing over 6.5 feet tall. Curiosity is packed with advanced scientific tools, including the ChemCam, which uses a laser to analyze rocks, and the SAM, Sample Analysis at Mars Laboratory, which studies the planet's chemistry. It also has a radiation assessment detector, RAD, to measure Mars' harsh radiation levels. On average, Curiosity can travel about 90 meters per day and has covered around 20 kilometers since it landed. Originally, Curiosity's mission was planned to last just 2 years after its 2012 landing. But thanks to its durability and the incredible data it keeps sending back, NASA extended the mission indefinitely. More than a decade later, the rover is still working, far surpassing its expected lifespan. Curiosity got its name from a 12-year-old girl, Clara Mie, from Kansas. Unlike previous Mars rovers that relied on solar panels, Curiosity is powered by a nuclear energy source called a radioisotope thermoelectric generator, RTG. This system, also used in NASA's Viking landers from the 1970s, converts heat from decaying plutonium-238 into electricity. The RTG gives Curiosity a big advantage. It can keep running through Mars's freezing winters and long nights when solar power wouldn't work. Even though its power output slowly decreases over time, it still provides enough energy to keep the rover operational. The RTG also helps regulate the rover's temperature. The heat produced from the generator is distributed through a network of tubes, about 200 feet long, that circulate fluid inside the rover, ensuring its delicate instruments stay within safe temperature ranges. This technology is crucial because temperatures on Mars can plunge to extreme lows, and without a heating system, Curiosity wouldn't survive. Curiosity's onboard computer system is designed to survive the harsh radiation of space and manage the complex operations needed for exploring Mars. It has 2 identical computers called Rover Compute Element, RCE, units that handle everything from navigation to scientific experiments. To ensure the mission continues even if something goes wrong, each RCE has a backup system ready to take over. This safety feature proved crucial in February 2013, when Curiosity's main computer encountered a problem with its memory, causing it to restart repeatedly. NASA quickly switched to the backup system, allowing the rover to return to normal operations without a hitch. Curiosity is also equipped with an inertial measurement unit, IMU, a critical tool that helps it stay balanced and move accurately across the rugged Martian terrain. This device continuously tracks the rover's orientation and motion, allowing it to make precise adjustments as it navigates the planet's surface. To communicate with Earth, Curiosity uses 2 different systems, a direct X-band transmitter and a UHF radio that connects to orbiting satellites like the Mars Reconnaissance Orbiter and Mars Odyssey. Because signals take about 14 minutes to travel one way between Mars and Earth, NASA relies on these orbiters to relay most of Curiosity's data. The satellites have larger antennas and more power, making data transfer faster and more efficient. However, since these orbiters follow specific paths around Mars, Curiosity can only send and receive messages through them for about 8 minutes per day. When it comes to studying the Martian environment, Curiosity follows a detailed step-by-step process. First, it scans the landscape with high-resolution cameras, including the Mastcom, Mahli, and Marty, which were developed by Malin Space Science Systems. These cameras capture sharp images from different angles, using adjustable focus and color filters to enhance details. If an area looks particularly interesting, Curiosity fires an infrared laser at the surface, vaporizing a tiny section of rock. By analyzing the resulting light, the rover can determine what elements are present. If a sample appears promising, Curiosity moves in for a closer look using its robotic arm. It places a microscope and an X-ray spectrometer near the target to gather even more detailed information. If further study is needed, the rover drills into the rock, collects powdered samples, and analyzes them with onboard instruments like the Sample Analysis at Mars, SAM, and the Chemistry and Mineralogy, CHEMIN, spectrometers. These advanced tools help scientists uncover the secrets of Mars's geological history and assess whether the planet may have once supported life. So what has Curiosity taught us? Let's find out for ourselves. Images from Mars by Curiosity rover. On August 6, 2012, as NASA's Curiosity rover descended toward Mars, the world was watching. NASA aired the event live on NASA TV, and the excitement was overwhelming. Millions of people tuned in to witness this groundbreaking moment, causing such a rush of visitors that NASA's website temporarily crashed. People from all over the world flocked online to see history being made. Once Curiosity safely landed on the Martian surface, it wasted no time in sending its first images back to Earth. These early photos provided a stunning view of the Martian landscape just moments after touchdown. One of the first images, taken on August 6, 2012, gave a close-up look at the surface near the rover's landing spot. While the dust cover protecting the camera lens during the descent was still partially in place, it gave a raw and unique view of Gale Crater. The terrain was barren, rocky, and bathed in a reddish-orange hue that has come to define the look of Mars. Then, on August 23, 2012, Curiosity captured a breathtaking series of images that showed Aeolus Mons, or Mount Sharp, inside Gale Crater. This was a captivating moment because the images presented different versions of the same scene, including the raw, unedited version and color-adjusted versions to highlight the details. The mountain stood tall over the rover, its layers of sedimentary rock offering clues to Mars's ancient climate and history. The raw image gave a direct, unfiltered view of the Martian surface, while the color-corrected ones revealed subtle differences in the landscape's hues and texture. A month after landing, on September 7, 2012, Curiosity took an incredible self-portrait using its Mars hand lens imager camera. This image was a combination of several photos stitched together to show the rover in its entirety against the Martian backdrop. The color correction on the image revealed the true colors of Mars, highlighting the rover's sturdy wheels and advanced science instruments. The photo not only showed the rover's size, but also marked its physical presence on the alien planet. On November 26, 2012, Curiosity captured another significant image from a location called Rock Nest in Gale Crater. This image showed a sweeping view of the Martian landscape as seen looking east toward Point Lake, with the distant Glenelg visible on the horizon. The scene was filled with flat, rocky terrain, scattered boulders, and fine dust, the typical characteristics of Mars. The camera provided both a white-balanced version of the image, offering a more true-to-life color depiction, and a raw version, which showed the natural, unaltered colors of the Martian surface. The difference between the two versions was striking. The white-balanced one highlighted the planet's red and orange tones, while the raw image displayed a more muted, natural look. But hold on, there is more to this story. Let's reveal the next rover after Curiosity, the Perseverance rover. Launched on July 30, 2020, as part of NASA's Mars 2020 mission, the Perseverance rover was built to explore Jezero Crater on Mars, an area scientists believe once had water and could have supported microbial life. Perseverance's main job is to study the crater's varied geology, from its sedimentary layers to ancient rocks that tell stories of volcanic activity and past water flows. Building on the successes of its predecessor, Curiosity Perseverance comes with new features aimed at boosting its scientific abilities. Though the two rovers are similar in body design, landing techniques, and power systems, Perseverance is equipped with exciting upgrades. These include advanced wheels, a more efficient robotic arm, and a sophisticated system for collecting and analyzing samples. One of its standout features is the MOXIE technology, which can pull oxygen directly from Mars's thin atmosphere, a groundbreaking capability. Since landing on Mars in February 2021, Perseverance has made remarkable discoveries, uncovering surprising details about the planet's geology, history, and the possibility of past life. For instance, its instruments have found that rocks at Wildcat Ridge, part of Jazero's sedimentary fan deposits, probably formed in an ancient lake. These rocks, due to their constant interaction with water, could hold the key to ancient microbial life. In addition, Perseverance has discovered different types of igneous rocks in Jezero crater, showing that the area has a much more complex geological history than scientists previously thought. This includes volcanic activity and water interactions, an important contrast to earlier beliefs that all the rocks in the crater were just sedimentary. Perseverance's radar system has also given scientists detailed pictures of what lies beneath the Martian surface, revealing solid rock and mafic material. The rover even confirmed that the crater floor had eroded before new layers of rock were deposited, offering even more evidence of Mars's active geological processes. The rover's microphones have also been put to good use, recording sounds of its activities on Mars. These sounds have helped scientists understand how sound travels through the Martian atmosphere, providing important clues about its density and composition, which is vital for planning future missions. One of Perseverance's most exciting partners on its journey was the Ingenuity helicopter, which it carried to Mars. Ingenuity made history on April 19, 2021, with the first successful powered flight on another planet. Over the course of 72 flights, Ingenuity proved that flying over Mars could open up new possibilities for exploration, offering a fresh way to study the planet's surface. Though it was retired in January 2024 after suffering rotor blade damage, Ingenuity's success demonstrated that aerial exploration could play a crucial role in future missions. As the rover explores Jezero crater, it's collecting valuable samples that will eventually be brought back to Earth for further study. These samples could unlock more secrets about Mars' ancient past. In the coming years, Perseverance will keep conducting geological surveys, gathering new samples, and testing cutting-edge technologies. Its discoveries, alongside data from other missions like NASA's emissions program and the Mars Sample Return Initiative, will help us move closer to the ultimate goal of sending humans to Mars and setting up a long-term presence on the planet. Perseverance rover images from Mars. The first test drive of the Perseverance rover on Mars took place on March 4, 2021, marking a historic moment as it left the very first wheel tracks on the Martian surface. As part of the Mars Sample Return mission, it gathered a variety of materials, including rock and atmospheric samples, which will help scientists unlock the planet's mysteries. The rover's ongoing mission has led to exciting discoveries, like the identification of leopard spots on a Martian rock. These spots could hold crucial clues about the possibility of life on Mars billions of years ago. Perseverance's journey has also sparked global excitement, with NASA's Send Your Name to Mars campaign receiving over 10 million names etched onto chips placed on the rover. This was a symbolic gesture of humanity's shared interest in exploring space. As a tribute to the healthcare workers who fought tirelessly during the COVID-19 pandemic, a special plate was attached to the rover, honoring their efforts. Additionally, Perseverance's parachute carried a hidden coded message, "Dare mighty things," a phrase that has come to symbolize NASA's ambitious goals. In terms of visuals, we've received breathtaking images from Mars. The Octavia E. Butler landing photo, taken in February 2021, was snapped shortly after the rover landed on the planet. It captures the powerful plume of smoke created during the descent, showing the intense force with which Perseverance arrived. Another photo, taken from the rear right hazard avoidance camera, offers a clear view of the terrain around the rover, showing how this camera helps guide Perseverance safely across Mars. On Sol 213, the 230th Martian day of the mission, a photo reveals Perseverance's parachute and back shell lying on a ridge about 2 kilometers away from where the rover is located. The surrounding landscape is full of interesting geological features, including the ripples in the Jezero crater. Perseverance also provided humanity with its first color image of Mars, giving us a vibrant view of the planet's reddish terrain, rocks, and dust. In a panoramic shot taken on Sol 14, after Perseverance's first long drive, we see the rover's tracks on the Martian surface, highlighting the vast and rugged nature of the planet's landscape. Another image taken on Sol 44 captures one of the rover's wheels, showing its footprint on Mars. A particularly fascinating image takes us back in time, showcasing an ancient river system that once flowed through Jezero crater. This discovery hints that Mars may have had water and potentially microbial life billions of years ago. We also have a stunning aerial shot taken by the Mars Reconnaissance Orbiter on February 26, 2022, which offers a bird's-eye view of the rover's position about Mars's surface features. The most recent images released by NASA show fascinating transits, like the one taken on January 19, 2024, of Mars's moon Phobos crossing in front of the Sun. Another image from February 8, 2024, shows Phobos moving across the Martian sky. In October 2023, Perseverance even captured a rare image of Mercury transiting across the Martian sky, giving us a fresh perspective of Mars like never before. What are your thoughts on the amazing 4K images of Mars sent by both rovers? Share your thoughts with us in the comments section. Don't forget to like and subscribe.